We're going to look at the case where we're solving a logarithmic equation where you have a sum of logs equal to a number. Our ultimate goal is to get our equation in the form of a log equal to a log, where we can use one-to-one property to eliminate the logarithms and then just solve the resulting equation, or get it as a log equal to a number. Right now we almost have that, but we have a sum of logs equals to a number. So what we can do is combine these two into a single log using what's called the product property. So if it were a minus sign, then we'd combine it using what's called the quotient property. But since it's a plus sign, we combine these two together as a single log called using the product property. So it's going to be the log of x plus 1 times x plus 4 base 5 equal to 2. So now we have the case where we have a log set equal to a number. At this point, we just simply change forms. So rewriting it as an exponential, we start with the base here. We're going to raise it to the second power, set equal to this quantity here. So you have x plus 1 times x plus 4 set equal to 5 to the second power. So on this side, we have a product of two binomials set equal to 25. So let's go ahead and multiply this out. So x times x gives us x squared. X times 4 gives us 4x. 1 times x will be x, and then 1 times 4 will be 4, and then 5 squared is 25. Simplify it by combining like terms. Combine the two x's together to get 5x plus 4 equals 25. So now we have a quadratic equation. So in this case, like we did in the past, we're going to set the quadratic equation equal to 0. So that means we're going to bring the 25 over, and the result would be a negative 21 equals 0. All right, so now in quadratic we have basically a couple options. We can either see if it factors, and then we can use the zeros from there, or we have to solve for the zeros using quadratic formula. In this case, we have to find two numbers that multiply to give us 21. That would be 3 and 7, and 1 and 21. Now, the result would have to be negative 21, so that means one of them has to be positive, one has to be negative, and the difference has to be positive 5, and that's not going to happen. So that means we're going to have to go ahead and use quadratic formula here. So go ahead and write x equals, the b value is 5, so that'll give us negative 5 plus or minus the square root of b squared, which would be 25, minus 4 times the a value, which would be 1, times the c value, which would be negative 21, all over 2 times a, which would be 2 times 1. Now simplifying the inside part, you can have negative 5 plus or minus the square root. We're going to have 25. Now since two of the numbers are negative, that's going to result in a positive. When you multiply them together, you'll get a positive 84. All divided by 2. Simplifying the inside to 109. All divided by 2. Okay, so now these are our two possible solutions. We're not going to call them final solutions yet. So let's go ahead and separate them into two separate solutions. So one would be negative 5 plus the square root of 109 over 2, and x equals negative 5 minus the square root of 109 all over 2. Now as they are now, we would consider these exact solutions until we actually convert the square root to a decimal, and then it becomes approximated. So the next step we're going to do is the approximated solutions, and I'm going to round those to 1 decimal place. So when you take negative 5 and take the square root of 109 divided by 2, you're going to get approximately 2.7. And when you do negative 9 minus the square root of 109 divided by 2, you're going to get approximately negative 7.7. Now these become approximated solutions because I rounded them to 1 decimal place. Now these are not my final solutions. I have to determine whether these are good solutions or not. Now logarithms have a domain of x values that have to be greater than or equal, or I'm sorry, greater than 0. It can't be equal to 0 and it can't be negative. So just because a number is negative does not automatically eliminate it from being a solution. It's when you take this number and plug it back into here or here and anywhere in the original, does that result give you where you have to take the log of a negative quantity? In this case, the negative 7.7, if you plug it in here or here, it's going to fail and it's not going to be a good solution. So we're going to cross this one out. The 2.7 is going to be your only solution. The solutions that are not good, we call them extraneous. Okay, an extraneous solution, it is a solution to this quadratic. It's just not a solution to the original equation.